Good morning.
Morning, Jeff. How's it going?
Very good, thank you. How are you? Can you hear me okay?
Yep. Still messing with my setup. I got my screens arranged like I normally don't, or differently from I normally do.
I can share the agenda.
All right.
Any screens open? You can come through now?
Yep.
Yep.
Looks good.
Starting off with lower attendance than I thought. I guess it is still just 2 minutes after.
Last week of the summer.
Yeah. Well,
Back to school for a lot of people.
most people are already back to school. Vacations are over. I guess it's late enough. Everyone on the call should know my colleague, Jeff Kennedy. I'm going to let him lead the meeting this week, let him kick it off. So, Jeff, go ahead.
All right, thanks, John. Hello, and welcome to the August 2025 OCP Server Project meeting. We do have a full agenda, including three presentations from folks who will be presenting at the Global Summit. The announcements are the APAC Summit completed in Taipei. Those sessions are available to view online. You can go to past events from the OCP website and see those. And, of course, the big news is we're less than 2 months away from the Global Summit in San Jose in October. First drafts of presentations are due to be submitted. The review cycles are beginning for those. In fact, tomorrow at this time, there is a training that you may have seen to go through the review process for those. Do we have Michael Schill on the call or Greg to talk about any steering committee or foundation level updates?
Yeah, Greg's here, Jeff. Nothing that you didn't cover, right? Like you said, Global Summit's coming up in 2 short months. So there's a lot of stuff going through steering committee, getting voted on between now and then. So just stay on top of it. If there's things that haven't been submitted yet and you'd like it published prior to OCP Summit, I really need to get that in front of the foundation very quickly.
This is Alicia. I'd just like to add that we do have 2 steering committee meetings set up for September to accommodate, but those agendas are already pretty full. So as Greg mentioned, if you do have a contribution that you're looking to be published prior to Global, definitely make sure that you get it submitted. I'm going to drop the link for the new contribution form in the chat and get that over to us as soon as possible. And then you can send me an email too, just so that it's on my radar.
Perfect. Thank you for the double confirm.
Yep. It's kind of a little anxiety inducing how full our agendas are. And I know that there's probably some some things out there that are not on my radar. So I want to make
Yep.
sure that we get everybody the opportunity that we can.
It always gets that way. Also, the Open System for AI workshops, it says there's a June, July, and August. Actually, the Photonics and Optical Interconnect for AI workshop is going to be September 9th. There's a register link in the upcoming events on the main OCP website if you want to go register for that that workshop.
So John and Jeff, this is Jack. I have a quick question. Kate sent out mail yesterday, said for our breakout session, everybody had submitted except for one session. Who's going to chase them down, or do you know if it got published?
I've looked at that, and right now the track sheet says they're all submitted, so that whichever one was outstanding must have already been
Okay,
closed.
thank you.
Okay, moving on to sub-project updates. Do we have Damien?
Yeah, Damon here. Let me try to share my screen.
Sure.
Working with a small screen today. Where is the share button? Oh, okay. Got a hidden. I have to open the whole thing. Okay, sharing my screen now, and then I'll make this bigger. Can you see my share
Yes.
screen?
Yeah, we can
Okay.
see it.
Cool. I couldn't see this. Let me make this smaller. Did I make it bigger? Okay. Okay, notice I'm blocking now. Okay, cool. Let's do that. So a beautiful agenda today as well. I have 5 minutes. So yeah, we do have like OCP corpus submission from the OCP NIC. Two presentation conditionally accepted. So yeah, we also submitted our draft. So waiting a review feedbacks from the track chairs. And then we also have an innovation village accepted. So per communication with Rob, we expect more info from OCP Foundation this week regarding like who do we partner with, and maybe potentially even get some guidance on how much space do we have. More works to be done. And then moving on to our DSFF thermal test fixtures. So reiterating that this new thermal test fixture intend to support all the form factors that we listed here, because it look big. So we do have question from our own folks in OCP NIC that whether it's just a DSFF test fixture, do we intend to design SFF ones? So the intent is no one fixture for all. And how we're going to do that is actually by using one fixture and then have different kind of brackets. However, this is a proposal, and this proposal is being provided to our thermal work stream. So the thermal work stream ultimately decided what is the best way to do this kind of testing, because like one discussion, especially around the SFF and TSFF, is like whether we put two cars or we put a blocker. Given that this is a thermal test fixture, we actually empower the thermal work stream to make that recommendation. How do you want to test it? Yeah. Then as for our SI work stream, so we are restarting the SI work stream. In fact, we're starting in an hour or so. Yeah. The intent is to set the SFF and the DSFF the limits for PCI's Gen 7. So a little bit of background that in the smaller form factors, we tend to deviate from the PCIe CAM to have a slightly more stringent insertion laws, parameters. The reason is because we would like to make sure that we have an edge, and then also it's achievable given that the size of the design is actually smaller. So we want to give more budget to other area of channels that we needed. So that's the reason why the SI work stream is being kickstart to like define how much is that for Gen 7. And then for thermal work stream, the first part is something that that the thermal work stream will actually get the thermal test fixture from Dell. Dell is the one that helped to design this, and then create a model, and then create the guidance. How do we test it for different form factor of OCP NICs? And the second part of the update from thermal work stream is regarding the liquid cooling. We do have discussion within the thermal work stream that we do have some challenges, but my usual updates in this kind of forum is the work stream update will go to the monthly update in OCP NIC, and then the monthly update OCP NIC will kind of proliferate to the server group. So the challenges that I will not talk too much here until we discuss it in our OCP NIC monthly meeting. So next month we're probably gonna bring some of those information to this forum. It's because we want to give our opportunity for OCP NIC folks to kind of try to see what's the best way and how to resolve things before we bring to the server group. And next update is regarding our form factor work stream. So we repeatedly being asked what we're trying to solve for. So there was more wordy text in the past update, but I kind of streamlined it to 2 bullet point for this. The first one is like the intent is to get a higher density, higher bandwidth NIC than what the SNIA PMM offering today. There's one. More like getting more bandwidth and density. That's first. That is has been consistent since we start this form factor workstream. The second one is more like a new thing that we look at it and we intend to do is currently the by32 solution on the NIC side is actually very bifurcated and very hard to converge. So if we were to define a new form factor, the intent is to converge it. So this is a visual representation of that. Like by 16, we do have like PCIe CAM and OCP NIC, pretty much the NIC form factors for the by 16 use cases, but by 32 was really bifurcated. The main reason of those bifurcation are we don't have a PCIe CAM by 32, I guess. If we have that, probably a lot of will be a by 32 the PCIe CAM, but given we don't have that, so different, we have an APAC form factor championed by Google. We have a by 32 by one more hyperscaler. We have a PMM by SNIA. We have another by 32 by hyperscaler 2 is actually a Microsoft. They are represented in the workstream, so I can now tell this is Microsoft. And then we have a by 32 from another prominent vendor. They're all by 32, they are slightly different. So there is a concept being proposed. We will go through a vote within OCP NIC and see like whether we can make one next gen concept for far ahead of some needs to kind of align to whether we can have one or few down the road. Because designing another by 32 to kind of make all the by 32 using the same one is very, very difficult. It's almost impossible in this time. I have offline conversation with a lot of folks. A lot of folks will be like, can we use mine as a standard? Because everybody said that it's very hard. So the intent is like create something far-fetched and we have time to define for things in the need for the future. That at least that's the proposal and the concept. It's currently being shared in the workstream. So workstream has that. As I said, we're gonna proliferate to the OCP NIC monthly meeting before we bring it back to server. But at least the bullet points are here. If you intend to look at the concept, either join the OCP NIC meeting next week, or also we'll bring it to the server group the next one.
Damien, at what bit rate do you think this by 64 will run?
Up to PCIe Gen 7 support.
Wow.
Currently, yes. It also depends on the pairing currently. Yeah, actually, we do have a slide that kind of show what kind of a lane, what kind of speed, and what kind of OSFP pairing we can support. Yeah. So actually, if you're interested, you can join our work stream. The work stream has a lot more discussion and this kind of pairing. Yeah.
Okay, thank you.
Back to you, Jeff. Sorry, I took more time.
Okay, thank you. Any other questions for Damien? Okay. So up next, MHS modular hardware system, some project updates. Do we have Brian or Sean?
Yeah, I'm here.
Hi, Brian.
Let me share. Looks like somebody needs to grant access. Oh, there we go. Can you see my screen?
Yes, looks good.
Okay. So in the August MHS public meeting, I announced that there was an interesting track in the AI ML IT systems workshop that folks might want to go check out. So I posted the YouTube link to that. Michael did a great walkthrough. The slides are in this deck that are posted to our wiki. But if you want to check out a preview of what we're going to present at Global Summit, I encourage people to go watch this 5-minute YouTube video on MHS for AI. As far as the workstream updates, we had an update from MCRPS, PNP, SCM, and MHS. So I'll just go through those real quickly. For MCRPS workstream, our power supply, basically we're still working on getting the version 1.06 spec out. It's been held up a couple of months now, but the good news is we finally got the issues resolved and working on finishing up the 1.06, and we expect to release that next month before Global Summit. So stay tuned for that update. It's coming soon. And then similar on our plug and play work stream, we're working on creating a 0.5 spec. For last Global Summit, we released the 0.3. The plug and play has a bunch of specs tied to it, base specs tied to it. And so the team is working hard on getting those published in September before Global Summit. And then since that is a rather meaty topic to discuss in our public calls, we plan on having a much longer, I think it's a 20-minute session at Global Summit it's more of a deep dive into these new specs. So we encourage you to attend the Global Summit, and if you can't attend, then listen to that recording. But the PMP leads will go into much more depth on these new specifications. So that's also coming in September. As far as our DCSCM workstream, we finally got out the revision 2.2 base specification. The biggest change with this specification is that it now includes the compact form factor DCSCM. This is the 1U tall. It can be vertical or horizontal, but the base spec, the pinout, the CAD, all that has been updated, published on our wiki, and is in the process of making its way through the steering committee into the contribution database. As far as our next work stream, we plan to move on to DCSCM 3.0, which may be different than our 2.0. And so that work stream, I know they've signed the CLA and they're making progress on setting up the goals and the scope and the constraints. So if you're interested in participating in defining the next generation DCSCM, please reach out to the workstream leads. As far as our HPM Common Circuit Type 2, which is for dual node designs, I'm getting a lot of feedback on the mic if somebody can go on mute. I think it's Samina. We're releasing the design spec 0.7 soon. And then the biggest news is that Casper, one of our longstanding SCM leads, is stepping down as a workstream lead, moving to a different company. And so Javier Laza, who's I think on the call, is replacing him as a lead with Tim Lambert. And then finally, our Edge work stream has been busy working on getting their first specification published. This is the 0.5 spec. So finally, they were able to get this published. It's available on the Edge MHS wiki, and they'll be talking about this at Global Summit. The only thing is, it might be a little bit harder to find because it's not grouped with MHS. It's actually under the Edge track on a different day. So if you're interested in going to this one, this is the track name. And Dirk, Dave from HP, and Rob from Cable will be talking about this new spec. They're targeting a 0.7 by September, probably a little bit ambitious, but hopefully to get a 0.7 by Global Summit with that feedback. And that's all I had. Any questions?
Brian and Damien, as it is clear that DCSCM now is part of MHS, DCMHS, that's a good convergence. Does it make sense for the NIC and MHS to also kind of collaborate more tightly and maybe work together? Especially since the team is looking at 64-bit connectors, and it will impact HPM very drastically.
I think we already work pretty closely together. We are grouped under the server project. If you look at our DSFF collaboration on our previous specs, that was all very tight collaboration. So I think that's already happened just by the nature of we're in the same project. DCSCM, if you remember back, I don't know, 6 months ago or whatnot, was actually not under server. They were under hardware management. So, you know, by grouping this under server does create that collaboration. So I feel like that's already there. But if you have something to suggest, please let us know.
So this is John. So one reason for moving DCSCM was the rest of hardware management. We really focus on APIs and didn't deal a whole lot with hardware. So the server group, server project dealt a lot with that. So it was logical to move it there.
Very good.
We just didn't have the expertise to go manage a hardware set of designs.
But Damien, feel free to speak up. I feel like we already work together. So if you have a suggestion, CMAC, on how we might improve, let us know.
For example, the concept of 64-bit slot running at Gen 7, is it being discussed at HPM work groups, and do we have ways to drive it?
Not yet. This is actually under exploration in the form factor work stream. We even ourselves yet to decide this is path that we're gonna go. It's just like a discussion for now. Once we decided this is where we want to go, we have enough supporter, then we will work through go through MHS. Just like when we do liquid cooling, we do enhance like the 1U exploration of the OCP NIC, that's where we go into MHS. Like those we know we want to explore. This form factor is early concept exploration. We have not go to MHS yet.
Very good. Thank you.
Mhm.
Any other questions?
Thank
All
you.
right, I'll turn it back over to you, Jeff.
Yeah, appreciate it. So next up, we have the AI hardware software co-design sub-project. Jack Harwood, would you like to speak to that?
Yep. Can you see my screen?
Yes, I can.
Okay, yeah, so I guess the only person who probably gotta go through, so Siamak was on our call last Friday. We had a little bit of a disagreement about some of the fabrics, kinds of things that we're working on, so probably before Global Summit, we'll rectify that with updating the white paper on some terminology, some pieces. To Siamak's request, I published a table on our Google Drive that we're going to start editing about different kinds of things, but it's really built around language of scale up, scale out. And it came out of kind of a proposal of one of the presenters for OCP Global Summit, kind of vectoring a little differently. So we're just going to try and rectify that before we end up at Global Summit. But we've really been working across HPC, compute, and data services on modeling framework that allows us to simulate a number of workloads and build this out. So from an ecosystem point of view, we can look at different things, different compute models, inference, as we connect in data service to inference. And through the Keysight team, we have a schema proposal that allows us to look at that from an AI point of view. We're part of the server NIC HPC breakout session. So we have 2 sessions that we've actually kind of included a little bit other content. So it covers the breadth of the working group. And we're the first 2 sessions on the Wednesday morning. And so both of those are in for review, but it's really built around the polymorphic architecture. The first one around enabling macro heterogeneity is around HPC. And the second one's really built about polymorphic for compute inference workloads and performance. As we settle into some future work, we do have a big push around neuromorphic. We're going to connect our simulation work and we're reaching out to the digital twin group that's emerging. And we've already talked to Rob and team about for the end of the year to keep working on kind of the standardization of the schema and to be perfectly clear as a way to cooperate with a number of other schemas and frameworks and JSON data that's already out there that we're trying to work on some pieces. But we're going to try and clean up some language, things like that before the Global Summit versus introducing confusion at the Global Summit. And then do that through our couple, we have 2 presentations in the breakout, one in the AI networking and one in the future technology. So we have kind of a smattering across the days. So, okay.
Any questions for Jack?
Thanks.
I don't see Alan Cantle online to speak to the HPC sub-project. Is anyone else present to speak to that?
Yeah, I haven't heard from Alan, so I'm surprised he's not on. He normally is.
Okay. And moving on to composable memory subsystem. Is it ready or Manoj?
I don't see either one of them. I can give you kind of a synopsis of it. So we've been continuing to prep for the OCP Summit. There are several demos in the Innovation Village, as well as interesting presentations with a lot of new information. There's a white paper that was done on the fabric management that is underway, will be published soon. CMAC, if CMAC is on, he can actually also fill in some blanks there.
Thank you, Mohammed. Yes, the team has been very active. There's going to be a more than half-day track around composable memory system presentations. It's going to cover disaggregated memory and fabric management and future of interconnects that might help with memory fabrics.
Yeah, there's a lot of focus nowadays also on discussions with AI benefit from fabric attached memory. So there's a lot of content on that provided from multiple companies, including CMAC's contribution to the white paper. Seagate has done also some contribution on the software side. So there's a lot of effort also being led to establish a TCO benefit by 0 Point and Seagate and others. So we're still transitioning to the next phase of realization of some of the solutions out there. We're seeing some composable memory systems starting to show up at FMS. So there are a lot of energy behind this. I think it's kind of coming out of the trough here and not limiting our focus on CXL, but on various fabrics that could lead to composability.
Right. As Mohammed said, a number of solutions are emerging. And it seems that people at academia, software guys, and others are asking for reference systems. So the team has been trying to find a way for the greater community to bring together systems in one form of prototypes or reference and be in some lab. One of the universities has raised hands that maybe Ohio State University, they can have a lab to host some systems. And within the broader community server, especially this team, could maybe start helping out, providing components or chassis or work to help set that up. It is in the works. It's looking for more support.
Thank you for that update. Any questions for Siamak or Mohammed? Next up, open chiplet economy. Yuan or Anu?
Both here. Let me try to share. I have just one slide and then we'll talk to it. Can you see my screen?
Not yet. There it is.
Okay. So I think right after this, we've got Brian and Helia talking about the control path spec. So I'm just going to mention that, and they'll talk about the work and the submission of the specification to the OCP. On the Global Summit update, we've got an all-day program on the 15th. So it's a pretty long list of speakers. We have 2 panels there. Where we intentionally left the panels a little vague to start with, because we wanted to see post APAC Summit if we could get some interest from that geographical region of people attending the Global Summit and who would make interesting panelists. So we're still working on trying to nail that down, working with Cliff to get that down. We have some submissions which haven't been made yet, so we're going to chase those down and get it in place. And then Javad's going to talk about the APAC Summit because he was there in person.
Yeah, so we had a pretty successful day-long session at the Apex Summit. The highlight for at least myself was that TSMC came and they participated in the program. So we identified one particular area that local industry is really interested in collaborating across their geographical region, and that is for silicon photonics and co-packaged optics. So there seems to be a big ecosystem forming around that topic. So we had some one-on-one meetings after our session to basically bring the OCP ecosystem of collaboration across the local industry. So a white paper is in the works now to form a local OCE group in Taiwan. So let's see how that experiment goes. But it's interesting that some of those folks are actually coming over to the global summit. So overall, there was a lot of learning for us, as well as I'm sure there was quite a bit of learning for the local industry, which is very silicon focused in Taiwan. So uh, we do plan to create or support this new group that will be Taiwan focused, though we are going to form it in a global spirit that will not be just limited to one location, but the times that we will pick for the weekly meetings of these work streams are probably going to be more friendly to Asia Pacific than US. So we'll report in the future how this experiment goes. That's all. Happy to answer any questions. And if not, then we can hand it over to our approval request and the presentation from our link layer work stream. So Heidi and Brian, go ahead.
Okay, one moment. Okay, slides should be shared. I'm Brian Murray from VeriSilicon. I functioned as the editor for this version of the link layer specification. Helia, who's also on the call, is the chair of the link layer working group. I'm going to talk really high level and briefly about what's in our 1.2 specification. For those that are not familiar, the 1.0 specification defined a protocol stack for basically transporting SoC bus protocols across a chiplet link, specifically on the BAU interface. It defines both a way to packetize bus transactions and a way to granulize and serialize those packets across a BAU interface. 1.2 doesn't really change any of that. We do a couple of minor tweaks here and there in terms of language clarification, but 1.2 is completely backwards compatible to 1.1. There's no real change in the behavior of the main band bus protocol over the main band interface. It adds a new sideband stack. BAU defines a set of just a small, slow speed serial link for sideband communication. And so 1.2 adds a way to packetize bus transactions over that slow serial link. And then we also add a control protocol for controlling the main band link, mainly with the purpose of doing bring up. These two layers work together. The link control protocol is primarily a register mapped based set of communication flows for doing this bring up and reading PHY state and doing any kind of other chip bring up you may need in that same vein. And then the BAU sideband is all about transporting that register based communication over the sideband slice. The sideband protocol as I mentioned, it's pretty simple packetization of these memory map transactions. We support both variable length transactions, but the packet size itself is fixed because performance is not a primary factor in the sideband communication. We support pretty much anything you would think of in terms of a normal memory mapped SoC bus. We also support ECC, but it is optional and it looks very similar to our main band ECC. The link control protocol is a little more complicated. It is a messaging system for doing PHY bring up. It supports, it's all over memory mapped registers, so it fits on top of the BIOS sideband protocol, but it could potentially fit over other types of sideband. There are existing implementations in the market that use things like I2C. And so if those implementations are memory mapped, then you can squeeze this over an existing sideband if you want to use that instead of BAL sideband. Though our spec is pretty much only concerned with BAL sideband, any other mappings to other protocols would have to be done external to the spec. It's the link control protocol because it's potentially mapping over other other types of sideband that may be a little more memory limited in address space and things like that. We decided, okay, well, what's the minimum we can define here? And so we define a message register and we define a state register on both sides of the link. This is bidirectional. And then the protocol focuses on how to construct messages that are then sent through these registers and pulled via the state. In order to accomplish this, it defines a set of bring up states. These are a little different than some of the PHY states you see up in the BAU and the main band side of the link layer spec, but these are specifically for bring up. And then, as I mentioned, it kind of gives you a mechanism for constructing messages. Now, the messages themselves are pretty flexible, but we define a long list of example messages so that people aren't too bogged down on exactly what a message should look like to do the most common functions. But if your system needs a variant of those things, you can construct messages for delivering that kind of functionality as well. Some examples are just setting up the link, doing link resets, a whole host of link training commands that are easy to do in terms of like setting patterns, playing them back, doing random numbers, that kind of thing. And then obviously identifying bad lanes that are identified through the test and things like that. Oh, I guess one of the like I said earlier, the bus is bidirectional. Sideband slices themselves are bidirectional, but there is a message register on either side of the link, and so the protocol does define ways of being able to respond to partners when they send you messages in your message register, and what the appropriate response is depending on what your link bring up stage is and the like. Any questions? Sorry, I might have rushed through that a little bit. Tried to keep it high level to fit the time slot.
Yep. Thank you, Brian. It was a short 10 minutes, and we have a little over 15 minutes to get 2 more in. So thank you.
Thanks, Brian and Hilliard.
Next up, Yosemite V5. I see we have Abe online.
Hi, yeah, I'm here. Let me go ahead and share my screen. Okay, you should be seeing my slide deck now. Let me know if you see that.
I see it.
Awesome. Let me go to presentation mode. Cool, we should be in presentation mode now. Great. So yeah, my name is Abraham Garcia, Abe Garcia for short. I'm a hardware engineer at Meta, based out of Austin, and I'm sharing the Yosemite V5 platform for Meta. This is for the specification contribution review. So the agenda overall, just gonna review the overall contribution summary, the YV5 overview, which includes kind of the more technical details, and then going through the OCP tenants. So the summary of what we want to contribute. So this would be the Wi-Fi platform overall. It is the latest compute platform at Meta, and it'll support various configurations and server types. So we'll be contributing just the platform at this time. Again, as we said here, there's different configurations. So based on those different configurations and their MP dates, there may be different contributions for those specifics. But this is the overall platform as a whole. So as a background on how we got here at Wi-Fi 5 is essentially with rack power availability increasing in our data centers, we wanted to develop a platform that was able to support a larger range of server density to allow ability to either scale up or scale down the compute power in a rack. In addition, we want to natively adopt the DCMHS DNO server form factor, as we'll see shortly here. So a quick overview of some technical highlights of the platform. So again, it is Meta's next generation compute platform. It is a 3U chassis or RV3 compliant. On par with our previous Yosemite contributions, it is modular and can support various configurations. Supports high TDP CPUs, so up to 550 watts. Also high memory capacity, so up to 16 DIMMs. In addition to, if you want to add even more on top of that, there are the Excel options to support even more on top of there, which I'll show shortly. Some notable components that are utilized in a chassis we want to call out are the DCSCM. So as we all know, the standardized module and interface that enables common management and security. The TSFF OCP NIC. So again, standardized module and interface to allow a disaggregated network solution. And then also the boot drive and data drives are E1S form factor. So they allow easy serviceability and are also power sufficient storage solutions. And then Wi-Fi 5 is air cooled, so modular fans will be on the chassis as well in the rear. So here's a kind of decent close-up look of the chassis. So on the top right, we have the front view of the chassis. Again, 3U. This configuration shows a 3-tray setup, 1U each. At the bottom right, we have the 4 fans at the rear side. So this configuration is considered a high memory config. So if you go to the left area, so you can see the front is a bit different from our image on the right. As we go to the MPI currently, some locations of drives have changed a bit. So the latest over here is the one shown with EBT is our latest config or latest form factor. So in the front, you can see 2 data drives. These are 25mm E1S. Going to the right, we have the DCSCM for our BMC. And then to the right of that is our TSFF NIC. And then just to the right of that, another 25mm E1S drive along with the boot drive, which is a 9.5mm size. If you look from the top, you can see the insides of this tray. So again, for the data drives on the left, we have those connected to a small, what we're calling E1S expansion board. And that's getting its PCI link through these 2 MCIO connections. So there's 2 MCIO cables coming over. And in the front, we have the DCSCM and NIC with the data drives here and the boot drive connected to a paddle board with the 1C connector and with the boot drive going to a 1C connection. Again, as I mentioned previously, so we have the 16 DIMMs that can fit in this tray, but then if you have an expansion board enabling CXL, you can enable additional, in this example is 12 DIMMs. So just showing a type of configuration you can use for this high memory config. And again, PCIe coming across via MCIO cables here. In the rear, we have this paddleboard. This paddleboard will contain the hot swap controller for 12 volts coming to the server. So it's removed from the server itself and removed from the power board in the rear and placed on this paddleboard. So it is a serviceable component or module. And this next image is a better picture of that. Yeah. Here's effectively the kind of the same configuration, high memory, but it's showing a different layout. So in the previous one, we showed sorry, how do I go here? There we go. In the previous one, we showed kind of a tray form factor with the expansion next to it. But in this next version, it's in the rear, so it can support a single blade as opposed to across a tray, which will take up 2 blades. So here's showing a better view of the paddleboard with the HSC on it. And then it's getting its power from the Medusa board. Medusa board getting its 48 volts from the bus bar at the rear with this Medusa cable. And then we have our power bricks here. So this will convert our 48 volts to 12 volts, which will be provided to our paddle boards, which power each tray or blade, however you configure your platform. And then this configuration, we have a 1 to 3 paddleboard cable. So each paddleboard has its own cable going to the Medusa board. And then from the paddleboard to the server, in this connection, we're using PIC power. So this is a 12P and 12S going to dual 6P, 6X PIC power connections. Again, depending on how much power you need to provide to your server, you have some flexibility there. And then showing their direct connection from the fans to the Medusa board here. And here's another just high level kind of a logical block diagram, again, showing what I've already shown here. So in this example server, we have the CPU going to the various the endpoints, so DCSCM, NIC, and the data drives. And then here showing the MCIOs to the CXL expansion. On the Medusa board, you want to call out, we will have a CPLD. So the CPLD will control the fans, and it'll also provide telemetry for any sensors that are on this Medusa board. So, and then we simplified the architecture a bit management-wise from the previous generation, where we have the BMC talking directly to the CPLD via 2 I2C buses. So one I2C bus is designated for one I2C bus is designated for sensor telemetry, while the other is meant for management, that can contain control for like configuration of the CPLD, reprogramming, and those kind of actions. I can probably provide an updated slide that has more of a management picture here, but I can show that whenever I share the slides. Here I want to show just an example rack configuration of Yosemite V5. So again, it is ORV3 compliant using a 600 amp bus bar. In this config, we have a middle of the rack wedge 400, and up to 12 chassis can be populated. Here we're showing different configurations that are possible with the Yosemite V5. So a minute ago, I was showing the high memory config, which is a single tray, 3 trays across. Here is a 1U, so it's more of a compute high density version. So here you can see up to 6 that you can fit in a single chassis. In this configuration, we have 2 trays essentially, which are that have a loft on it for additional E1S. So for disaggregated storage use cases will be a good option for this 1.5 tray. Another one is additional flash with a loft style flash, just loft style area for the E1S drives, with the front having access to each individual server having its own NIC and DCSCM. And then in this 3U blade over here, just another option for accelerator options where we have different abilities to put a CAM adapter or a PCI card in there along with your flash storage in the front. So just like all our previous generations, many different configuration types that can be supported in a single chassis. Only delta being the actual trays or blades of the server config you use within the chassis itself. Going along to the tenant area, the tenant section. So openness. So we do plan to, for the Wi-Fi specification, it describes which design can be used. It describes a design that can be used to maximize power availability and support many configuration types, and can be leveraged by other OCP partners, or it can drive other use cases with support for expansion options or OpenBMC and ORV3. Efficiency. Wi-Fi will utilize a modular open standard components such as DC, MHS, and DNO server form factor, DCSCM, OCP NIC, ORV3 racks, and OpenBMC firmware. Impact. With high power data centers becoming more prevalent, Wi-Fi allows for higher utilization of available rack power, while at the same time simplifying some of the management architecture and keeping its traditional modular architecture as previous generations had. Scale. It is designed for large-scale data center deployment and operations. It will maintain its traditional design for ease of serviceability, high-level telemetry, and reliability as a focus. And sustainability. So Wi-Fi 5 has been designed to allow future reuse of chassis and modularity support allow upgrade capability, in addition to Wedge 400 reuse and memory reuse via CXL. And that can be either reuse of DDR5 with CXL or DDR4. And that's it. I went to that pretty fast. Now we're out of time, but yeah, that's the conclusion of the Wi-Fi 5. Any questions or anything else?
Abe, do you have enough requirements or spec submitted for people to build the CXL module separately or order it separately?
Yeah, so in the base platform, that'll be part of the specification contribution is basically how to enable different configurations, or basically show what's exposed and available that would allow you to enable different configurations. For the actual, solution each potential user wants to enable, that'll be up to them on how they want to enable that, but we'll describe the usability of the Wi-Fi 5 itself to allow that to happen.
Again, the structure of the contribution here, is it somewhat modular that one can select that, okay, all I need to do is to, you did have a diagram show the CXL memory cartridge, memory module. So if somebody wants to adopt only that, is it specifically defined so as a base spec, design spec, and product spec that somebody can build that one and incorporate it in some other chassis?
Yeah, so this specifications for the chassis overall. The chassis can be used for different type of configurations, but what you're saying is specifically a high memory config, there would be a separate specification for this exactly. It will show the actual more details on the server, its interface to the expansion board, and the tray itself. So yes, there would be a separate dedicated spec with a high memory config like this.
Right, very similar to your chassis is using DCSCM as a module. And adopting the particular definition of DCSM or NIC3 that goes into this chassis. If somebody wants to grab one of these components, such as CXL board, since it is kind of emerging right now, that's what I'm focusing on.
Yes,
so
that would be available for.
Yeah, this could be a separate thing that somebody can incorporate at Edge or DCMHS or some other place.
Exactly. Yes. Anything that we release after this for a specific configuration, those would be contributed, and the specific specifications would also be contributed, which you would have access to.
Okay. Thank you.
Okay. I'll go ahead and stop sharing.
Yep. Any other questions for Abe? Next up, Matt Bowman.
Perfect. Let me share my screen. Just double checking folks are able to see it.
Looks good.
Perfect. My name's Matt Bowman. I'm a hardware engineer at Meta. I'm going to talk about Clemente, which is our next generation AI ML server that we're using. I first wanted to give the scope of what specifically are we contributing, and it is the compute tray that goes within our rack. We have other things that we use in the rack, like the HPR power supplies, the BBUs, the RMC, and there's other contributions as well from, say, NVIDIA that do the NVLink switches. So what I'm talking about today and what's in the scope of the contribution is specifically this compute tray. I did want to cover kind of the background and motivation before getting into the specifics. About 3 years ago, we contributed Grand Teton to OCP. It was a lot of custom hardware. It leveraged the HGX baseboard from NVIDIA, but beyond that, the form factor, the switch tray, the actual motherboard, all of that was custom hardware we designed and built. Earlier this year, we contributed Catalina. This was our GB200 implementation, and probably the best way to describe it was directionally aligned or MGX inspired, where the HPM and the structure of the 72 GPU pod was definitely aligned. But when it came to how we do power, how we do PDB, all of the little helper boards, they were custom. We kind of aligned it to meet the interface needs, but we redid and respun most of the boards. Today, I'm talking about Clemente, and it's continuing this trend of basically more leveraged hardware, stronger alignment. This gives us a few advantages of faster time to market. It also decreases our risk. We have a wider pool of validation, less isolated, more unique bugs. Grab it, build it, go is kind of our goal, especially on the AI things with these aggressive time to market schedules. If I break out and look at the tray itself, kind of what's going on it, on the rear side, you can see the 2 HPMs. So these are where the CPU and GPUs are, along with our CX8 IO board. This is a mezzanine that plugs into the HPM. All of this on the right side of the tray is in and part of the cold plate loop. So it's liquid cooled on the right side. The fans in the middle give a nice delineation. Everything on the left is air cooled. And this is primarily where our customization or unique flavor was added to the design. Most of it was accomplished through this interposer. That is a brand new board that we designed and built to support this. It acted as a shim. So essentially we could take the exact same PDB that the MGX uses, the exact same OSFP, the exact same E1.S NVMe, and really glue together these parts. So the interposer is doing a lot of translation and connectivity usefulness. The other big inspiration of doing this specifically was to pull in a lot of these common OCP components that we've kind of standardized and used. I'm glad Abe actually went right before me, because we have a DCSCM, we use E1.S drives, we have OCP NICs. We're very much aligned in these commodities that we want to use in the OCP ecosystem. If I jump to a breakout of what did we specifically change from the MGX, these first two are architectural differences. This is how we want to handle and do leak management and control and shutdown in the data center. We have, oh, what happened? My Chrome crashed. Sorry about that. We have an RMC that connects up, controls shutdown. We still want the option to the BMC to stay alive, or if it's a more catastrophic leak, a complete shutdown. We needed to redo how we handle and control the standby power in that scenario. We also need to be able to connect to the RMC to handle that. So we added and incorporated the front IO board that gives us the leak sensing and control cable connectivity. These next three are the commodity or OCP alignment changes. So using OCP NICs, the E1.S OCP NVMe cloud drives, and the DCSCM. These last two were much more tactical. The interposer I mentioned is doing a lot of this translation so we can incorporate the new with the old. And then we took some steps to optimize the PDB heatsink. Because we redid the bays of the MGX, we ended up with some extra room. We wanted to take advantage of that and make the heatsink a little more efficient. Real quick on the detail block diagram, when I showed the top-down view, you can see physically it's 2 HPMs. Logically, though, it operates as one large server. So each HPM has one gray CPU and 2 B300 GPUs. If you look at this red line in the middle, that represents the C-Link connection. It is a unified memory space. There is one OS running on this whole tray, and we make use of that. So it's a 2-to-4 ratio of CPUs to GPUs. For our implementation with the OCP NICs, we add that and use the NCSI connection. So you can plug in, have the one data cable that gives you your management as well as data connections. And then we have mentioning you have one boot drive. So total 5 E1.S drives in the tray. One is operating as a dedicated boot drive, while the rest are data drives. Real quick on the power side. So we are at the ORV3, 48 volt. Our distributed voltage is the 12. So we're still at the time where we take in the 50, we convert a 12. That's generally distributed to everything throughout the system. So it's the PDB that's doing this conversion, the hot swap control, all of that. Our standby power and the fans. In our management scheme, where you have the NCSI, the OCP NIC needs to stay online and powered. The DCSCM needs to stay powered. And because those front components are air-cooled, the fans also need to stay on. They go to some nominal speed so that when you are in a shutdown mode where the hosts are off, you still need the fans running to keep the front end NICs cool. The mechanical is, if you're familiar with Catalina or the MGX style, it's directly leveraged. So we are using an ORV3 rack, but the tray itself is in fact a 19-inch tray, and it's one RU instead of one OU. This lets them get the density and the alignment, and from the MGX side of it, you have the compatibility in both ORV3 and the standard 19-inch racks. touching on thermal real quick. So it is hybrid cooled. We have the air cooled on the front of the tray, liquid cooled on the rear of the tray. When we redid these front bays, so MGX has the notion of these customizable modular bays, we ended up with extra room. We brought the dividers forward. That gave us some room so that the reference heat sink that's on the PDB, in fact, could grow. We could have some basically fin extensions in evac areas, get more surface area. We can more effectively cool the PDB so that our fan speed can dramatically get less, both during idle times and under load. The PDB is converting all of the power, the 48 volts to the 12. So it actually has some thermal constraints that we wanted to put some extra attention on. I'll touch tenants real fast. We're already over time, but openness, on the open side of it, we're aligned to all the OCP contributions. That was the starting point of, can we use the DCSCM? Can we use the OCP NICs? How do we start back and connect to the rack management controller? And at the same time, we want to contribute it and grow the ecosystem. Efficiency, one very specific example is being able to reduce the fan speed, get it in, run this, power is becoming actually a bigger and bigger bottleneck. So having the tray not only take less power, but cooler temperatures, better reliability. From a strategic standpoint and maybe impact, what we're seeing is getting quick time to market while keeping risk as low as possible. That is a win-win across the board. And the way we've gone about doing this is adding modifications to get our necessary design, but in a very targeted way, and being able to leverage validation data, not be on some island, some unique bugs that would, could be showstoppers. From the scale side, particularly around the leak management, how we're doing our sensors, our telemetry, and the reliability side of it. Not only do you need that because AI clusters, if it's not reliable, it's not useful. If you constantly have interruptions, servers dropping, you're not going to be successful. So you actually need fairly reliable hardware or a quick way to figure out why something is failing to get it back up. Sustainability-wise, because of this commonality and leveraging these common components, both in our previous Catalina, as well as alternate like YV5, for example, we have this very good circularity of being able to both reuse, supply chain simplifications, and we also are able to leverage and work with our vendors when they know what we need, they can better produce them using green energy and resources. And that was it. I went super fast because we're over time, so I certainly love any questions or comments. Yeah.
Yeah, thank you, Matt. Any questions? Okay, any wrap up work stream or initiative updates?
The presentations will be on the wiki, right?
I believe all three presentations we saw today are intended to be contributions and presented at OCP Global Summit.
Yeah, we would like to get them on the wiki. I don't think we actually have those presentations yet. If the presenters would send them to us, we will get them on our wiki.
For sure.
Thank you, John.
I'll wrap us up, John.
Yeah, I think that's all. Thank you for everyone for joining today, and we'll talk to everyone next month.
Thank you, everyone.
Thank you.